Linear versus exponential functions. You use technology to find the linear and exponential equations that best fit the given data. In growth and decay problems, that is, problems involving a quantity increasing or decreasing, here's how to decide whether to choose a linear function or exponential function. If the growth or decay involves increasing or decreasing by a fixed number, use a linear function. The equation will look like y equals mx plus b, where m is the rate of change, the slope, and b is the initial value, the y-intercept. If the growth or decay is expressed using multiplication, words including like doubling, halving, something like that, use an exponential function. The equation will look like f of x equals the starting amount times the base to the x power. A is a library has 8,000 books and is adding 500 more books each year. So the first year it adds 500, the second year 500, the third year 500. That's a fixed amount each year, so that would be linear. And the original amount would be 8,000. So it'd be y equals 500x plus 8,000. That would be your equation. Let's look at C. A bank account starts with $10. Every month, that amount of money in the account is tripled. Linear exponential. Well, the first year, you would triple it, and that's $30. The next year, you'll triple it again. That'd be $90. You add a different amount each year. That's going to be exponential. So this was A, and then this was B. So we're going to have y equals 10 times triple means 3. 3 to the x power. Try the rest of these, A through E, on your own, and then we'll go to number 2. Okay, let's look at number 2. Decide whether the table represents a linear or an exponential function. Circle either linear or exponential, then write the function formula. Okay, when you're dealing with tables, you could do a regression for each on the calculator. Another way you can find it is if you take the x and you see if you're adding or multiplying. And you look at the y and see if you're adding or multiplying another number each time. Okay, so if we have a positive, that means it's going to be some kind of power. If we have adding and then multiplying, that would be exponential. For this page, let's go ahead and just do for first sum and first sum, that would be linear. And then first sum and first multiplication, that would be exponential. There's other patterns that you could get as well, such as sum and then second sum, that would be quadratic. So if we look at A, we're adding 1 each time for the input. And then for the output, let's see, 5 minus 2 would be 3. 8 minus 5 would be 3. 11 minus 8 would also be 3. So we're adding the same number each time. That means it's linear. So the equation would be y equals mx plus b. M is rise over run, which is 3 over 1, so it'd be 3x plus your b, which is 2. Okay, let's look at the next one. So we're adding 1 each time. And then 6 minus 3 is 3. 12 minus 6 is 6. We're not adding the same number each time, so let's see if we can multiply the same number. 6 divided by 3 is 2. 12 divided by 6 is also 2. 24 divided by 12 is 2. So you're multiplying by 2 each time. So this is going to be exponential. Y equals 3 times 2 to the x power. Try the rest of this section on your own. After you're done with this section, move on to the last section.